Hi Phil, I just want to run through the problems that you had for chapter 8 and 9 here. Sorry to get to it so late, it's been a hellacious week. But it looks pretty good just from what I've seen. So, first problem, you have a confidence interval. That's good. Absolute value, margin of error is that because the standard deviation x bar is just 1. Add and subtract it. And I like that. That's okay. Yeah, that looks good. Okay. Problem 2. Again, another confidence interval. Okay, so let's see. Okay, that looks good. And your standard deviation of x bar is that. Okay. Okay, that looks good. Okay, good. This one's a little tricky. So this is a statement about a confidence interval, and you have to be careful. There's a lot of different ways to interpret the confidence. So, intuitively we all know that this is saying we think the true mean is between this and this, but what's the confidence about? So the confidence, I'll tell you what it's not. It's not the percentage of people that spend that amount of time. Okay? That's a different thing. That's the proportion of the population. I'm interested in the average time. Okay? So this doesn't tell us the percentage of people that are between that. So this answer, strictly speaking, is going to be wrong. The other thing that it's not is it's not the probability that a person is going to be in here. So this confidence really is a statement about the method. Okay? That's the most I want to tell you for right now. But basically, it's a statement about the method. So go back to the readings and kind of look back over this. This is hard. The confidence part is kind of hard. Let's see. So then at 8.2, let's see, 11, we're doing a confidence interval. Okay, let's see. So the margin of error. Right. I think there's a difference that I have. I'm trying to think of... Oh, I know why. I apologize. I'm looking at the wrong problem in my notes. Everything looked right in your paper. I was saying, why don't I have the same thing? Because I was looking at a different problem. That looks good. Very nice. Very nice. Okay. Yeah, and for 12... let's see, we just want I believe we want the critical value. Okay. Let me see real quick. For some reason, my value is a little different. Let's see. I'm trying to think of why that is. 0.01. Oh, I know why. Because this is the 0.01. So alpha here is 0.01. That's why it's differing. Yeah, so it's not 0.05. It isn't always 0.05. When it's not stated, it's going to be different. But this should be 0.01. Okay, but everything else is good. You just have to change it to 0.01. Okay. So the next problem is an interesting problem. Everything looks good that you've done in this part of the problem. So up to this part, everything's fine. Now, what we have to kind of think about here a little bit is what this confidence interval means. In this confidence interval, notice that this is what we think the average amount per person the store loses that does this showrooming. Okay, so this is where we think the true average amount that the store loses per person who showrooms is. So the next, basically, it's the next 1,000 people. We're going to multiply this by 1,000. Okay, and so that's what we want to do here. And this gives us an estimate for the average amount of money we think the store is going to lose on the next 1,000 people. Okay, so this you want to take into account the fact that this is per person, and for 1,000 people we want to multiply it by 1,000, and then we have to write down the interpretation. Okay, let's see, for 9.1. Right, so we want to know if we're going to reject or accept, and exactly, this is one way of doing it. We could also compute the p-value. You computed the critical value. That's fine. For 4, you could do it in terms of the p-value or the critical value. Either one's fine. The 9 looks good. Okay. Let's see. Okay, that looks good. Yeah. Yeah, this is a little, maybe a little nuanced. This is what, you're right, this is what they're in favor of. Basically, they don't want a drug that's safe to be rejected. So they want to try to minimize that. This one, the answer is in the book, so this is one that you want to go back and look over. There actually is a way that you can reduce both, all right? But you have to look in the book. But there actually is an answer for that. Let's see, for 14, we're doing... right? Okay, so you're doing a critical value, which is okay. We've been doing the p-value, but that's perfectly fine. Okay. And of course you know what the p-value is. You want to make sure that you know what that is. And then you're doing a confidence interval. And that looks good. Okay. Okay, so now we're doing another confidence interval where we don't know the standard deviation. Whoops, sorry, first we need to look at the hypothesis test here. I missed that part. Okay. Right, we fail to reject. Okay. Okay. P-value looks good. Okay. Okay, confidence interval looks good. And the conclusions are the same. That's right. So whenever you reject the null hypothesis for mu naught cannot be in the confidence interval. Good. All right. Section 9.2. Okay, for 18. We want to do our test statistic, and sure enough, test statistic is 2. That's good. Okay. For 19, we should have 15 degrees of freedom because it's 1 less. Right, it's left skewed, but the sample's small, so we can't use it. This is okay because the sample size is large, so that one's all right. And the book gives you a little bit of a hand-wavy explanation of when you can do it. Basically, when the sample size is large, that kind of trumps skewness in a sense. Okay, so now this is the candy problem in 925. Okay, so you're computing the critical value. All right. Let's see. I believe though you're not going to reject here, so I think you want to go back and look at this. Basically, your test statistic ends up being minus 1.5, and you're doing significance level at 0.05. So 0.025 is 1.96 for the z-score. So something's not quite right there, I don't think. All right. Yeah, so 25, you want to look at it again, and I can't really tell what you've done too much because there's not a lot of work done, so I don't really know what values you put in and where you've got them, so I'm not quite sure. I know one thing that's wrong is the standard deviation. I can tell that this is definitely wrong. Okay, and that's probably the reason why you're getting. But that actually wouldn't make. That would even make less sense. I think if you put in the larger standard deviation, you should. Yeah, I know that's wrong. Yeah, I would definitely look at that again. I know the standard deviation of X bar is not right though. Okay, let's see, 31. So I guess I just need to see work here. I don't know. I mean, I'm not disputing that it's true, but I just don't see any work to substantiate that. And you'd have to make a histogram to show this. Let's see. Yeah, so then this kind of goes to what we're trying to do in B. We basically are going to make a histogram to show that. And let's see. For D, well, this assumption again, you have to kind of go back and look at that. So the assumptions for using a t-test are in the book. So I go back and just kind of check those out. All right, it looks pretty good overall. As a general comment, I would say that I think you do the best work when you label everything. When you go a little more freestyle and you don't label things, then the work is harder to follow, and it doesn't seem that it's quite as good a quality. And I know you're trying to get stuff done. I know you're playing catch up and all. I get that, so that's understandable. But maybe that's something to keep in mind. Okay, technically they're due on Friday, but if you need a little more time, that's fine, because I'm getting this back to you so late, and I apologize for that. All right, thanks.